Today we're exploring rapamycin, a molecule with a truly remarkable story, a story that spans from remote islands to cutting-edge laboratories. Today we're exploring rapamycin, a molecule with a truly remarkable story, a story that spans from remote islands to cutting-edge laboratories. Discovered in the 1970s in a soil sample from Easter Island, a place shrouded in mystery and ancient history, rapamycin was first noted for its antifungal properties, initially seen as a potential weapon against fungal infections. But its real breakthrough came when scientists realized, after years of dedicated research, it could suppress the immune system, offering a new approach to managing immune responses. This discovery was pivotal, making organ transplants far more successful and improving the lives of countless patients. Approved by the FDA in 1999, after rigorous testing and evaluation, rapamycin became a lifesaver for transplant patients, offering them a chance at a healthier, longer life. Yet the story didn't end there. In fact, it was just the beginning of a new chapter. Researchers noticed that rapamycin extended the lifespan, showing promise in areas beyond transplantation, of simple organisms like yeast and worms, sparking curiosity about its broader biological effects. Even more surprising, it worked in mammals, a significant leap in understanding its potential, hinting at a possible link to the biology of aging itself, opening up exciting new avenues of investigation. This shifted rapamycin from a transplant drug with a specific and limited application to a hot topic in longevity research, capturing the attention of scientists worldwide. Could a compound from remote island soil, a substance seemingly so simple in origin, help us all live longer, healthier lives, defying the natural processes of aging? The idea is tantalizing, sparking hope and excitement, but the science is complex and requires careful study. Today, rapamycin stands at the intersection, a focal point, of medicine and the quest to slow aging, representing a new frontier in health and wellness. Let's dive into how it works, exploring the intricate mechanisms behind this fascinating molecule. Rapamycin's remarkable power stems from its profound effect on a critical cellular pathway. This pathway is known as mTOR, a complex and highly influential system within our cells. Think of mTOR as the master switch, the central command center, for cell growth and metabolism. It dictates whether a cell should focus on building and expanding, or on conserving resources and repairing damage. When mTOR is active and fully engaged, cells are in a growth phase, readily dividing and multiplying. They're focused on expansion and replication. However, when mTOR is inhibited or suppressed, cells undergo a significant shift. They transition to a state of maintenance, prioritizing repair and self-preservation. Rapamycin works by effectively blocking mTOR, acting as a brake on the growth pathway. This sends a signal to the cells, instructing them to initiate a comprehensive cleanup and recycling program, targeting damaged or dysfunctional components. This vital process is called autophagy, which literally means self-eating. This cellular housekeeping, this internal spring cleaning, is absolutely crucial for maintaining overall health and cellular integrity. And it is believed that this process plays a significant role in slowing down the aging process itself. By cleverly mimicking the beneficial effects of calorie restriction and intermittent fasting, rapamycin effectively encourages cells to prioritize long-term survival and resilience. It does this over the potentially detrimental effects of unchecked and rapid growth. This is precisely why scientists are so excited about its potential, believing it could impact not just one specific disease, but the very trajectory of the entire aging process, offering a chance to extend health span. Instead of introducing something entirely new and foreign into the body, rapamycin cleverly activates and enhances our body's own innate renewal and repair systems, boosting our natural defenses. And that's the core secret behind its incredible promise and potential for the future. The idea of a life-extending pill sounds far-fetched, but lab evidence is compelling. In yeast, worms, and flies, rapamycin consistently increased lifespan. The real excitement came when mice given rapamycin, even late in life, lived significantly longer and healthier. Treated mice showed better heart function, reduced cancer, and improved cognition. These results suggest rapamycin targets a core aging mechanism, not just one disease. However, mice aren't humans, and our biology is more complex. Still, the consistency across species hints at a deeply conserved pathway. This strong lab evidence is why human trials are now underway. But what do we know so far about its effects in people? Human trials are just beginning, focusing on health span rather than lifespan. Early studies show rapamycin-like drugs can boost immune response in older adults and may improve markers of aging. Researchers are testing if low intermittent doses can enhance heart health, reduce inflammation, or sharpen cognition. Meanwhile, some biohackers and longevity enthusiasts like Brian Johnson have experimented with rapamycin off-label. Their stories are intriguing but anecdotal, and not a substitute for rigorous science. These experiments have brought rapamycin into the public eye, fueling debate and curiosity. But real answers will only come from controlled clinical trials. Until then, the promise remains unproven. Excitement aside, rapamycin is a powerful prescription drug with real risks. At high doses, it suppresses the immune system, raising infection risk and causing side effects like mouth sores and metabolic issues. Longevity research uses lower intermittent doses, but long-term safety is unknown. Notably, longevity guru Brian Johnson stopped taking rapamycin after noticing worsening lipids blood work and elevated resting heart rate along with recurrent skin infections. His experience is a cautionary tale. What works in mice may not work for everyone. The effects of long-term mTOR inhibition in healthy people are still a mystery. Self-experimentation carries real risks. Caution and patience are essential as we learn more. So where does rapamycin stand today in the ever-evolving landscape of longevity research? It's a question that sparks considerable debate and warrants a careful, nuanced examination. Animal studies are promising, offering a glimpse into the potential benefits. These studies are showing extended lifespan and health span across various species, fueling excitement in the scientific community. The mTOR pathway, a key regulator of cellular growth and metabolism, is a compelling target, but rapamycin is not a simple supplement that can be taken lightly. Side effects are real and need to be carefully considered, and the long-term impact of rapamycin in healthy humans remains largely unknown, a significant area of ongoing research. The story of Brian Johnson, with his intensive biohacking regime, reminds us that even the most data-driven and meticulously planned approaches can sometimes lead to unexpected downsides and potential medical complications. The safest and most responsible path forward is through well-designed and rigorously conducted clinical trials, not self-prescription or experimentation. For now, the mainstream medical advice is to exercise patience and wait for more robust evidence from these trials. Rapamycin undoubtedly represents a potential paradigm shift in the way we approach aging research, but that excitement must be carefully balanced with a healthy dose of caution and critical evaluation. The best and most reliable anti-aging strategies still remain the tried and true methods: a healthy and balanced diet, regular exercise, and of course, refraining from smoking. The search for a safe and effective longevity pill continues with great intensity, and rapamycin is currently leading the way in terms of research and attention. But it's crucial to remember that the journey is far from over, and much more research is needed.